Hi folks, we're looking at page 578 number 3. So they give us this function here in part A and they want us to find f prime at 3. So of course first we have to find the derivative function and then we can evaluate it at t equals 3. Okay, so let's find the derivative here. So first thing is I have the logarithm of this expression, so I'm going to have to use the chain rule first, and then of course when I find the derivative of what's inside the bracket I'll have to use the quotient rule. Okay, so let's start this whole thing inside the brackets, my u. So the derivative of log base 2 of u is 1 over u ln 2. Okay, so 1 over u, which is t plus 1 over 2t plus 7. Okay, all times ln 2. Okay, and now I multiply that by the derivative of u with respect to t. So now I'll have to use the product rule, the quotient rule. So derivative of the numerator is 1 times the denominator function, okay, minus the numerator function, t plus 1 times the derivative of the denominator, which is just equal to 2, and that's all over 2t plus 7 squared. Okay, so here, if I wasn't asking you to simplify, leave it as it is, but let's do some simplification. So here we've got 1 over this fraction, so that's the same as 1 times the reciprocal. So this can be written as 2t plus 7 in the numerator, and then here we still have the ln 2, and now we have t plus 1 in the denominator. Okay, and let's simplify the numerator here. So here we have 2t minus 2t, so the t's cancel out, so that's quite nice. And then we've got 7 minus 2 is 5. So the only thing left in the numerator is 5, and I've got my 2t plus 7 squared. And here we can actually reduce these two t minus 7's, and so in the end we're just left with 5 over ln 2 times t plus 1 times 2t plus 7. Okay, and that's your final answer. Okay, let's take a look now at part B. Let me just get that. So part B gives us h at t, okay, is equal to log base 3 of log base 2 of t. So log base 3 of log base 2 of t. And we want to determine h prime at 8. Okay, so again, first thing we have to do is calculate the derivative and then evaluate that. And I just realized in part A, I forgot to evaluate f prime at 3. Okay, so let's do that here. F prime at 3, sorry about that. Okay, so that becomes 5 over ln 2 times 3 plus 1 is 4. Okay, and then 2 times 3 is 6, plus 7 is 13. Okay, so if we want to leave it as an exact answer, it's 5 over, so that's 40 plus 12, so that's 52 times ln 2. Okay, and that's about as far as I expect you to go. Of course, you can get an approximation, but in this case here, there's no context, so I would expect you to leave it as an exact answer. Okay, so let's get back to part B here. So first we have to take the derivative. Okay, so again, we'll have to use the chain rule first, so this will be our u. So the derivative of log base 3 of u is 1 over u, which is log of 2 of t, okay, times the natural logarithm of the base, which is 3. Okay, now we multiply that by the derivative of u with respect to t. So derivative of log base 2 of t is just 1 over t ln of 2 in this case here. Okay, so in the end, let's see what we're left with. We're left with just 1 in the numerator, and so we're left with ln 2 times ln 3 times t times log base 2 of t. Okay, and there's our derivative, and now let's find h prime at 8. So h prime at 8 now will be 1 over ln 2 times ln 3 times 8 times log base 2 of 8. Okay, and we can do a little simplifying here because log base 2 of 8 is just equal to 3 because 2 exponent 3 is equal to 8. So we can simplify that to 1 over 8 times 3 is 24 ln 2 ln 3. Okay, and that's the exact